Hello everyone, welcome to Coders Camp. So today in this video we are going to cover 01 knapsack problem. So before understanding the concept, let's understand the problem statement. So we are given a set of items and each item has some weight and some value. Also we are given a knapsack with some maximum capacity. So we need to find the maximum value of items that we can accommodate in this knapsack. So consider relating this scenario like a thief is entering into a house with a bag. What would he think? He wants to steal items which are more valuable and he can carry them in the bag he has. So he has to pick the items in such a way that the total weight is less than or equal to the given limit and the total value is as large as possible. So consider this example. The maximum weight or capacity of the given bag is 8 and what are the possible items we can put onto this bag. So now we can fill items of 8 kilograms. Now starting with 1 kg and 3 kg and 4 kg, the total comes to 8 kg and the value these three items are going to have is 110. So now other option we have is considering this 1 kg, 2 kg and 5 kg. This also sums up to 8 kg that we can fit into this bag and the values this thing is gonna give us is 60. So now the thief wants to steal maximum value items. In this case, these three items are valid that we can take, which will give us the maximum profit or maximum value. So we are going to pick these three items into our bag. So consider this example. The first item has the weight of 7 kg. If we are trying to put this item into this bag, then the overall capacity is filled with 7 kg and left with 1 kg space. So the items we can put rest into this bag should be 1 kg. So if you consider the next two items 3 kg and 5 kg, we cannot put any of this item into this bag as it may overgo the capacity. So if we fill this, we cannot fill any other options here. The same way, if we are ignoring this 7 kg, then we can put both 3 and 5 into the bag, which will give us $40. That is the maximum value we can get from these three items into this bag. So now here the challenge is pick the items so that we maximize the value within the given capacity. This problem is called 01 knapsack because we can either pick the item to knapsack or reject the item and move on to the next item. That is, we cannot break any item and put the half into the bag and leave the rest. So if we are picking the item, then which means it is gonna be 1. If we are not picking the item, we identify that as 0. So here, if we are picking the first item and leaving the next two items, then that can be represented as 100. Same way, if we are picking only the second item, then it can be represented as 010. And if we are picking only the third item, then it can be represented as 001. And if we are picking first two items and leaving the third item, then it is going to be 110 and it goes till it reaches 111. So here, if we are having 3 boxes, the possibility we are going to have is going to be 2 power 3, which is 8. Same way, if we are having n boxes, then the possibility of considering all this is going to be 2 power n. And the time it takes to solve this problem is exponential time. So we can solve this problem in better time by either in recursive way or using dynamic programming. So here in this video, we are going to see bottom-up dynamic programming. So let's say our value and weight are going to be represented in the form of integer array and we are given an integer value bag capacity. So if we are considering the first item, it is of weight 1 and value 20. So we have two options, either to select the item and put that into our knapsack or leave the item and go to our next item. So now if we are accepting the item or selecting the item, then from overall capacity of the bag, it subtract the weight of the item we picked. That is, here the maximum value is 8. If we are picking the item of weight 1, then the rest or the space given in this bag is going to be 7 kg. And we will have the option to pick only items further in future, which sums up to 7 kg only. The same way, if we are not picking the item, then the overall capacity is going to stay the same as the previous state. So it is nothing but a state of having the item in our hand or bag or not having the item in our bag. From this state, we move to the next object and consider the second object. Now our second object is of weight 2 kg and value 30. So further from here, you will have two options to each object, either to consider or not consider picking this object. So now if we are considering and not considering the objects, the values are going to be this. That is, this part says we are considering both two objects, that is first item as well as the second item. So now from the overall capacity 8, it reduced to 7 as the weight of the first item is going to be 1 kg, and from the 7 kg we have taken the second object of 2 kg, then it further reduces to 5 kg. So to reach this state of 5 kg and value 50, we should have accepted both the items before. The same way, if you see this side, we are not accepting the first object as well as the second object. So at the end, the maximum capacity is going to stay the same capacity as that of the bag's capacity, and the value is going to be 0 as we have not picked any item yet. So if we are going to use dynamic programming, we are going to represent these states in the form of two-dimensional array DP, whose indexes represent the number of items and the weight of the items given. So starting at the initial stage where it starts from dp of 0, 0 and it moves to this direction by considering the weight of 1 kg, and it becomes dp of the next item of 1 kg. So the first index represents the item and the second index represents the weight. The same way in this direction we are moving on to the second item, but the weight is going to be 0 as we have not picked any item. So further the next stage is going to be dp of 2, 3 as we have accepted two items and of 3 kg, because the first item is 1 kg and the second item is 2 kg. The same way here it's going to represent dp of 2, 0 because we have reached or considered two items but we did not accept any item, so the weight still is going to be 0. So if you consider the state of 1, 1 moved to 2, 3 by accepting weight of 2 kg, that is we moved one object away and accepting 2 kg will reach you to the state of 2, 3. So by using this concept, we are going to have a two-dimensional array DP and we are going to fill the values and arrive at our solution. So every time to fill our DP array, we will have two options, either to accept the item or reject the item. So if we are rejecting the item, simply it is going to stay the same. The value is going to stay the same as that of the previous value because we have not accepted any weight and the value did not increase. Where in other case, if we are accepting the item, from the previous weight item, we are going to add the value of the item we are accepting. So by using this simple formula, we are going to fill our DP array. So let us have a two-dimensional array DP whose columns are going to represent the weight or the maximum weight given in the problem statement. That is, here the maximum weight of the bag is 5 and the columns represent from the values 0 to 5. The same way, the rows are going to represent the number of items given. So here the number of items given are 4. So the rows are going to represent 4 items. So now each cell is the solution for a sub-problem and we finally arrive at our bigger solution by solving each sub-problem on the way. That is, if I am sitting in this cell, then this cell represents the solution for considering 2 items and the maximum capacity of the bag is going to be 3. Suppose if I'm sitting in this cell, then which means considering 3 items and the maximum capacity of the bag is going to be 1. Same way, this last cell represents considering all 4 items and the maximum capacity of the bag is going to be 5, which is the actual answer we need. So we are going to start from the leftmost cell 0, 0 and start filling the value towards the rightmost end cell 4, 5, and by solving each subproblem we arrive at our optimal solution and finally return the value at this cell. So if you consider the values, if we are not accepting any value, then the value is going to stay 0 till the last how many ever iteration we go. So we are going to fill in our first row with all zeros, as if we are not accepting any values. That is, here the rows represent the number of items. If there are 0 items, we cannot pick any item. So it is all going to be 0. The same way, if it is of 0 weight, then we cannot pick any, we haven't picked any item. So we are going to fill all columns as well with zeros. So now it's time to fill each cell by using this formula. So before filling the value, consider the maximum capacity is 5 and the weights given is 3, 2, 1, 4. So now the possibility of filling the bag is going to be 3, 2, which gives the overall weight to 5, or 1, 4. So now if you add the values of 3, 4, it is going to give us 40 plus 30, which is 70. And if you consider 1, 4, the value is going to be 20 plus 10, which is 30. So the solution that gives us the maximum value is to pick the items of weight 3, 2, and we have to arrive at the solution 70 at the end. So we are going to check whether this DP array is going to give us 70 in the last cell. So let's do this now. Here the rows represent the number of items given, and the values of the items are going to be 3, 2, 1, and 4. So now we are going to start from the leftmost cell. So here the item is going to be the first item and the weight is going to be 1. So now if we are trying to put the item 1 into weight 1, it is not possible because the weight of the first item is going to be 3. So we cannot pick the item, so the value is going to be 0. So again the weight is 2. We again cannot fit the item 1 into the capacity of 2. So again it is going to be 0. So now coming on to the third cell, where the capacity of the bag is going to be 3 and the item 1 whose weight is 3. So if we are picking the item, then we can pick only this item because the maximum capacity and the weight is equal. So in this case, if we are picking the item, the value is going to be 40 because that is the first item's value given in the value array. So we are going to fill 40 here. So now moving on to the next cell, here the capacity of the bag is going to be 4 and the item we consider is going to be 1. So in this cell you have two options, that is either you can pick the item or not pick the item. So first, if we are not picking the item, then it is not going to add this value but stay in the same value as in the previous step. So if you look at the previous step here, it is 0. So we are going to put 0 because we are not picking the item. So if we are picking the item, the value we are going to get is 40. Plus, if you see, if we are picking the item of weight 3 and the maximum capacity is 4, you still have 1 kg left in the bag to fill. So in this case, you can pick any item of weight 1 kg. Go directly to the cell in previous row of weight 1. Here, what is the value? So the value is 0. So you can fill this value only in this bag. As the weight of the item is 3 and the maximum capacity is 4, you can fill 1 extra kg and the value at 1 extra kg is 0. So here you have to put 0. So the maximum of 40 and 0 is going to be 40. So we are going to fill 40. So now moving on to the next cell, where the item is number 1 whose weight is 3 and the weight of bag is going to be 5. So now in this case you have two options, either not to pick the item. So if we are not picking the item, the value when the bag capacity was 5 is 0. And if we are picking the item, then we take the value of 40 plus the item's weight is 3 and the bag's capacity is 5. So if you put the item 1 into the bag, you still have 2 kg left. So if you go directly to the place where the item is 2 kg in the previous row, then the value is 0. So if you add 0 to 40, the maximum of 40 and 0 is going to be 40. So we are filling 40 here. So moving on to the next row, where the item is number 2 and the weight is also 2. And first we are going to put the item into the maximum bag's capacity as 1. So in this case, it is going to be 0 as we cannot fit this item into the cell. So now the capacity of the bag is going to be 2. The item's weight is also 2. So if we are picking this item, then we cannot put any other item into the bag, as the maximum capacity is filled by picking only this item, and the value you're going to put is going to be 30, as the value of the second item is 30 in the given array. So moving on to the next cell, the maximum capacity of the bag is 3 and the weight of the item is 2. So in this case, you have two options, either to pick the item and not pick the item. So if we are not picking the item, the value in the previous row was 40, and if we are picking the item, we are definitely going to pick the item and the value is going to be 30 plus the item's weight is 2 and the maximum capacity is 3. So if we are picking this item, we still have 1 kg left. So in our previous row, the value at cell 1 is going to be 0. So we are simply adding 0 here. So the maximum of 40 and 30 is going to be 40. So we are filling 40 here. Moving on to the next cell, the maximum capacity is 4 and the weight of the item is 2. So here we again have two options. If we are not picking the item, the value at previous cell was 40. So if we are picking the item, we are definitely going to take the item's value plus the rest of the space in the bag is going to be 2. So in previous row, if you check the cell 2, the value is 0. So we are simply going to put 0 here. And the maximum of 40 and 30 is going to be 40. We are filling 40. So now moving on to the next cell where the capacity of item is 2 and the maximum weight of the bag is 5. So here we have two options. That is, if we are not picking the item, then the previous row's value is 40. And if we are picking the item, we are going to pick the item. So the value is going to be 30 plus the overall capacity is 5 and item's weight is 2. So if we are picking the item, the space remaining in the bag is going to be 3. So we can, from this 2 item, pick an item of weight 3. So in this case, our previous item, item number 1, whose weight is 3, so we can pick that item. So instead, simply, we are going to check in our previous row at cell 3, is there any value? Yes, there is a value. So we are going to add that value here. So which is giving us 70. So from maximum of 70 and 40 is going to be 70. So I'm filling this cell 70. So it is simply the weight is 5 and the items we can consider is only 2. That is of weight 3 and 2. So here we pick the item 2. So then now for the rest of the space, that is of 3 kg, we can pick one item. So we are searching, is there any item of weight 3? So in our previous row, we can check only in previous rows because till here we are considering only 2 items. So we are checking in our previous row, is there any value we got by having the maximum weight as 3? Yes, we got something and we added that to our cell. Hope you are getting the logic. So now we are moving to our next row. It is getting familiar now. So now we are going to pick the item number 3 or consider item number 3 whose weight is going to be 1. So now the maximum capacity is going to be 1. So here, if we are picking the item, the value we are going to get is 20. So we are filling 20 here. Moving on to the next cell where the item's weight is going to be 1 and the maximum capacity is going to be 2. Here we have again two options, so either to pick the item or not pick the item. So if we are not picking the item, while we considered first 3 items, the value when the bag's capacity was 2 was 30. So now we are going to not pick the item, then the value we had already was 30. So if we are picking the item, we are going to pick the item's value as well. So it is going to be 20 plus what is the extra kg left. So now the weight of the item is 1, the bag's capacity was 2. So if we are picking the item, the rest or the extra space remaining is going to be 1. So in our previous row, what was the value at cell 1 was 0. So simply we are going to add 0 here for the calculation, and the maximum of 20 and 30 is going to be 30. So we are going to fill the cell with 30. So now moving on to the next cell, the options we have is not picking the item, so it is going to be 40, and if we are picking the item, the value is going to be 20 plus what was there in the weight of 2. Since the weight of the item is 1 and the bag's capacity is 3, we have filled 1 kg and rest of the 2 kg. In our previous row, the value was 30, so 20 plus 30 is going to be 50. Maximum of 50 and 40 is going to be 50. So moving on to the next cell, if we are not considering this item, then the value in the previous row was 40. And if we are considering the item, the value of this item is 20 plus the remaining kg is 3. So in our previous row, the value at cell 3 is going to be 40. So we are going to fill 40 here. So overall 60 and 40, the maximum is 60. So we are going to fill 60 here. So finally moving on to the cell 5, and if we are not considering the previous value was 70, and if we are considering this item, then we are going to add $20 plus the rest of the weight is 4, and in previous row the value at cell 4 is 40. So overall out of 60 and 70, the maximum is 70. So we are going to fill 70 here. So moving on to our last row, and the item's weight is 4. So we cannot pick the item as the maximum capacity is 1 and 2 and 3 and finally 4. If we are picking this item, the only item we can pick is going to be this. So the maximum value we are going to get by picking this item is going to be 20. So now finally moving on to the last cell, which is going to be our solution. Here we have two options, either to pick the fourth item or not pick the fourth item. So now if we are not picking the fourth item, the value at the previous row, that is considering the first 4 items and the bag's capacity of 5, was 70. And if we are picking this item, then we are going to add the value 20. As the item's value is 4, we have filled a bag with 4 kg, and the rest remaining space is going to be 1. And in our previous row, if we check what is there in the cell 1 was 20, and if you add 20 with this 20 is going to be 40. So now the maximum of 40 and 70 is going to be 70, and we are going to fill 70 in our last cell, which is actually the maximum value we can get by picking the items of maximum weight 5. So hope you understand the concept of 0-1 knapsack problem, and the code looks something like this. So here is a simple code for 0-1 knapsack problem where I have declared my DP array of length, number of items and the maximum capacity. So we are iterating for two for loops I and j, where I is the rows that represent the number of items and j is the column that represent 0 to maximum capacity given. So we are going to check if it is the first row or the first column, then the value is going to be 0. If not, the weight of the item is greater than the maximum capacity, then we can't pick that item at all. So we are simply going to put whatever the value was there in the previous cell. Otherwise, we are going to check the condition, which is the maximum, either by picking the item or not picking the item. So finally, our output will be at the last column or the last cell of the DP array, which is DP of the maximum number of items and the maximum capacity. So hope you're understanding this code. So here we are going to have the DP array of length, number of items into maximum capacity. So it is going to take time complexity of big O of number of items into maximum capacity, and also it is going to work in the same complexity. So hope you understood the concept and enjoyed the video. So if you like the video, hit like and subscribe. Thanks for watching Coders Camp. Thank you.